Hi guys, welcome to today's lesson. So today we're going to be focusing on linear equations, right? But firstly, we're going to look at what is an equation on its own, and then how does it then become linear? And then we'll also look at, are there any other different equations that we need to know out there? How many solutions do they have? Are they able to be solved? All of those questions, we're just going to try and answer that in this particular lesson. But for now, let's look at our leading question for this particular lesson. So, have you ever thought about what is the difference between an expression and an equation? Remember, we've been talking about a whole lot of things that have to do with an expression, expanding, factorizing, and all of those other things. But now, how does an expression become an equation, right? How many solutions does it have? Is the solution of an equation the same as the solution of an expression? What makes them different? What relationship does an expression have that makes it different from it being an equation? All those questions is what we're going to try and answer in this particular lesson. But firstly, let's look at our map. Our map is, we're going to look at what we call algebraic equations. There's different types of them, although for you it will only be certain types that you're going to focus on and not all of them. We have linear, we have quadratic, we have literal, we have cubic, hyperbolic, and an exponential equation, right? So all of these are different types of equations. There might be some that are left out, but it might be just because we don't really do them in our syllabus. Now, we're also going to look at solving linear equations, and there will be three main concepts that you need to know there, which is the additive inverse, the multiplicative inverse, and the reciprocal. The keywords for this lesson is, remember I said, we're going to look at firstly, what is an equation? And then, what makes an equation to then become linear? What does linear mean even? That's the other thing that you can even think about. When I say something is linear, what is it that it means? Now, an equation, according to mathematics, it will be a mathematical statement consisting of an equal symbol between two algebraic expressions. So we've been looking at all these expressions, right? If I have one expression, another expression, in between them I have an equal sign. We then call it an equation. And most of the time, what you need to know about an equation is it represents a relationship between two expressions, because that equal sign in between means that this expression must be equals to this expression, right? So that's why the equal sign is between the two expressions. Now, the equal symbol means that the two algebraic expressions have the same value as I just said now. Now, an example of this, I just want you to know the different language or vocab that we use for an equation. So if I have 5x plus 9 equal to 24, firstly, the 5x plus 9 is just an expression. The 24 is just an expression. The equal symbol means that the expression on the left must be equals to the expression on the right in value. But let's look at what is the expression on the left. The expression of the left, on the left rather, has what we call a coefficient, which is normally the number in front of a variable. It has what we call a variable, which you guys know it as alphabet. When we started doing language, we spoke about alphabet. So we use X most of the time in math, but it's not the only one. And then we have what we call a constant. A constant will be a number on its own. Even 9 is also a constant. So it's not only the 24. And then lastly, my equal symbol, as I said. Now, the different types of equations that I just want to show you. Linear will be the one that I just showed you now. So let me show you. A quadratic equation can be x squared plus 2x equals to 3, right? This is a quadratic equation. Why quadratic? Because of the exponent 2 there. We're going to go to linear equation and see exactly what makes it to be linear. We also have a cubic equation, which can be x cubed is equals to 8, right? X cubed equals to 8. Because of the 3 there as the exponent, we call it a cubic equation. We also have a hyperbolic equation, which will be like 2 over x minus 2 equals to, you can say, 5. This is an example of a hyperbolic equation. And then lastly, the exponential equation, the literal, we'll talk about it at a later stage. The exponential equation will be 2 to the exponent of x plus 1 equals to 16. It doesn't really matter. These are just made up things, right? But they are mathematically correct. Exponential because the variable is part of the exponents. That's how we call it an exponential equation. But for this specific lesson, we are only focusing on the linear equation. Linear equation will be an equation of one variable that has a power of 1. Why am I saying a power of 1? It means that the highest exponent is 1 of all the variables that we have. Then lastly, a linear equation has only one solution. That's the very main thing that you always need to know there. Now, when you say, quickly just back to the one that we did, we said it was 5x plus 9 equals to 24, right? This has an exponent of 1 there. That's what this means, to say it has a power of 1, and it will always just give you one answer or one solution when you are trying to solve this particular question. So if we try and solve this, which I will give you a step-by-step breakdown later on, you will just say this is 5x. I'm sure by now you have done this. 24 minus 9, it becomes 5x equals to 15, and then lastly I will have x as equals to 3, right? But for now, don't really worry about the steps of getting there, because we are going to break it down very soon as to what are the few steps that I want you to write down in order to be able to solve any linear equation, no matter how it looks. And trust me, some of them might look very dangerous and very scary to say, how do I solve this? But it's very possible to do that. But for now, let's take a quick ad break and I'll be back with some more. Stay tuned.